this we can handle. Okay. You'll learn more. If you take third semester calculus, you'll learn more about this because sometimes it can make sense. The dummy variable, if I write integral from 0 to 1 of e to the x du, the dummy variable, so the variable inside the integral is u. And x is constant relative to that integral. So this would be equal to e to the x. X is a constant, e to the x is a constant. And that would be e to the x, antiderivative of 1 is u. So we get e to the 1 minus e to the 0. Now this one, dummy variable is theta. And antiderivative, now e to the theta is not a constant. It's a function. Antiderivative of e to the theta is e to the theta. Go from 0 to 1. No. Okay. That's right. Okay, but I did this wrong. Okay. E to the 1 minus e to the 0, that's e minus 1. Okay, but only after, this is a constant. And I put my x's into, okay, I put the 0 and 1 into e to the x instead of into u. That's wrong. Use the variable. So this would be e to the x times u minus 0, times 1 minus 0. And that's just e to the x. Yeah, so this means something different. If I've got an x and a u, relative to the integral, u is the variable. All the other letters are going to represent constants. And here I can pull that e to the x out because it's not a function of u. Okay. But here I can't pull e to the theta out. And it means something entirely different. Does that help, Mr. Drake?
I believe so. So doing it, deciding whether it to integrate with respect to x or y does not change the function.
No.
It just changes. It just changes how I'm marking everything.
Yeah, you just gave it a different name, basically.
Okay, that's what I was checking because I wasn't sure or what to do there.
Okay.
I can only see y I to the x, and I couldn't figure out what that meant, so I wanted to be sure before I did anything else.
Okay, yeah, you don't want to try to integrate when you've got this situation. Not if u is a variable and x is a variable. Okay. Yeah, you want to get it all in terms of u or all in terms of x. Okay, so, let's see. I did check on some things. Okay, let's see. Your final, okay, final is Thursday, December 3rd. From 8:30, from 8 till 10:30. Again, I'll post it on Blackboard a little early. You can get started. You should have plenty of time because the final is only going to be like 1.5 the usual exam length. Let's see. So this is the online, and I must be able to see you on camera. If I can't, or if you have internet problems or whatever. Then there's a backup time. Okay. So in case you have internet problems or whatever, the backup time is Monday, December 7th. And it's 8 to 10:30 also. And this is, okay. And this will be on campus. Yeah, where I usually use room 114 in Lucas if it's empty. But I'll just find myself, if it's not empty, I'll find another room. And I'll be sitting there probably working on my other exams. And if you have to take it, then you just come in, get your exam, and sit there and take it way across the room. Okay. Everybody's separated. But that, yeah, in case problems happen, and they have so far. So, yeah. But for the normal time, Thursday, December 3rd, 8 to 10:30, and I got to be able to see you on camera. You can get started a little bit early if you want some extra time. And yeah, so that would, if I started at 7:30, that should give you 3 hours. That should be plenty of time to take that exam. Okay. Yes, and it does count. It will be.
And Professor Kennedy, I think I saw someone enter the waiting room earlier.
Okay. Yes, you did. Okay. Thank you. Okay. Let's see. Yeah, we'll wrap things up Monday. Over the holidays, I plan on getting your grades up to this point together. So that'll be everything. Exam 1, Exam 2, Exam 3, and all your homeworks, except for the one that's due this coming weekend. So you will know exactly what you have going into the final. Okay, so let me just try to, I'm just going to work one problem from each homework. Okay. Yeah, studying, going over the homework problems is a good place to start, certainly. You've had 10 homeworks and 3 exams. I would go through, start with the first homework. Okay, it seems like ages ago now. Make sure that everything is fresh in your mind. Make sure you're comfortable with everything. So review it and remember how to do all the problems. And, sometimes students who've had a sort of a hard time keeping up and not quite getting it before everything's due and whatever, but they've kept trying the entire semester. I find that sometimes those students, when they start going through everything and putting it all together, all of a sudden everything clicks and they do really well. We usually have one student from each class that'll do something like that. But yeah, I will notice if you do well. I will definitely notice. Okay, so a problem. From the homework that was on due August 28th, but okay, that was hurricane time, so I think I actually, oh, well, that was all messed up. I remember that. Okay, so I'm going to do 2C from the August 28th homework. And that was a limit problem. It's the limit as h goes to 0 of h minus 1 cubed plus 1 over h. Okay. Now, if a function is continuous at a number, well, the number involved here is 0. If it's continuous at 0, you can use direct substitution, right? You can just plug in 0 for h. Well, this function is not continuous at 0. If you plug in 0 for h, you would get minus 1 plus 1 over 0, which is 0 over 0. I put that in quotes because that's not a number. Anytime you get 0 over 0, it means you don't know, okay? It means you have more work to do because this is what you call an indeterminate form. Indeterminate really means anything can happen. And you need to look more closely at your problem. So direct substitution will not work. And what could you do here? Well, I'm going to expand that h minus 1 cubed. And that's, okay, binomial formula, which you don't have to know. You can multiply it out. It's h cubed minus 3h squared plus 3h plus minus 1. It goes plus, minus, plus, minus. Okay, plus 1 over h. And the 1's set out. All right, so then you've got the limit as h goes to 0 of h cubed minus 3h squared plus 3h over h. Can't plug in 0 here either. Still get 0 over 0. Keep looking. But now every term in the numerator has an h in it. So I can factor an h out of the numerator. And now, okay, remember when h is going to 0, when you write that, h is never equal to 0. You're not really interested in what happens at equals to 0, okay? H is not equal to 0, so I can factor out those h's. And then you have the limit as h goes to 0 of h squared minus 3h plus 3. Well, now the 0 over 0 problem is finally gone. It went away right here when I factored out those h's. And now you can just stick the 0 in for h, because now you're down to a continuous function, a function that's continuous at 0. And you get 3. Okay. What if I varied that a little bit and I said, find the limit as h approaches 1 of h minus 1 cubed plus 1 over h? Well, the fact that that's 1 instead of 0 makes all the difference in the world, because h minus 1 cubed plus 1 over h is continuous. At 1. It's not continuous at 0. It is continuous at 1. And you can just then use direct substitution. When you got continuity, you can use direct substitution. That is, just plug in 1. So this would be 0 plus 1 over 1 is 1. So pay attention to what number that is. Okay, any questions? Can you all still hear me?
Yes, ma'am.
Okay, good, thank you. All right, how about a problem off the September 11th homework? And September 11th, we were, okay, this is limits as x goes to infinity and minus infinity, also more continuity problems, and calculate the derivative using only the definitions. Let's do one of those. How about it? This is September 11th, number 6. I can guarantee you're going to have a limit problem, at least one, just plain old limit. And I can guarantee you I'm going to ask you to calculate the derivative using only the definition. When I say use only the definition, if you use one of the differentiation rules to do it, well, it's not that you got the derivative. The answer was incorrect. It was, I asked you to do it this way, okay? And I won't give you any credit. All right, so this function is that. Now, okay, so when I say using only the definition, there are two possibilities here. You could use the h goes to 0 definition. So this is that. Or you could use the x approaches a. We did that one. Oops, that's supposed to be a. Okay, over x minus a. When I say use only the definition, I mean use one of these. Let's see. Well, which one would you rather? Okay, I'm not going to do both of them. I don't have time. Would you rather I did this way or that way?
How about limit of x approaches a?
Okay. Thank you, Mr. Levy, for making a choice. Okay. All right. So f prime of a, the limit as x approaches a, f of x minus f of a over x minus a is the limit x approaches a. Okay, my function is the square root of 2x plus 1, so over x minus a. Okay, so this is a square root, and we have this little trick, I guess you'd call it, that only works for square roots. As in when you want to get rid of them legally. So I'm going to take this. Okay, so that's the same thing, but I'm going to multiply by the conjugate of the numerator. That's what it's called, the conjugate, which is the square root of 2x plus 1 plus the square root of 2a plus 1 over itself. Yeah, so I'm really multiplying by 1, which does not change my problem. But what it's going to do is let me get rid of the square root in the numerator, okay? Because so I'm using the fact that x minus a times x plus a. Well, the middle term goes away, okay? So that's going to give me 2x plus 1, square root of 2x plus 1 times the square root of 2x plus 1, and then minus 2a plus 1. That's this times that, okay? And there is no middle term because you got plus square root of 2a plus 1 times square root of 2x plus 1, and then also a minus square root of 2a plus 1 times square root of 2x plus 1. The middle term adds out. So I've eliminated the square root in the numerator. It's still in the denominator. But it's not really a problem in the denominator. And now, okay, the ones add out in the numerator, and then I've got 2x minus 2a. Oh, I didn't. Okay. I'm not recording, I don't think. Am I? Well, I'm just reviewing. I don't guess it matters anyway. Oh, well. Okay, so this is a limit as x approaches a. 2 times x minus a over x minus a. And now the x minus a's will cancel out. They're factors in both the numerator and the denominator, so I can cancel them out. And right here is when the 0 over 0 problem goes away. Okay. Now I'm down to a function that is continuous at x equal to a. And now I can plug in. Yeah, this function and this function are exactly the same, except when x is equal to a. So I'm carefully using the fact that as long as I'm looking on the limit, it's when I've got that LIM x approaches a, x is not equal to a. But I'm finally down to a function now that is continuous at a.
Shouldn't the numerator be 2?
Yes. Thank you. Thank you. You keep me honest, Mr. Levy. Okay, so now I can plug in the a for x. Okay, so it's 2 over 2. Okay, so we got that f prime of a 1 over the square root of 2a plus, oh gosh, okay. There, that was more like a 2. Yeah, so f prime of a is that, and that's the same thing as saying if I change the name to x, okay. And I didn't do it up here. Okay, when I was taking the limit as x approaches a, well, it's really important that I have 2 different letters, all right? Because the a is playing the role of a fixed value, and then the x is I think of the x moving towards a on either side. Okay. So in the limit, x and a have very different meanings. But after I'm finished, a is just a name. I can call it x if I want to. Okay, and let's see. Our function was the square root of 2x plus 1. And let's do it using the differentiation rules to check. Well, I'm going to use the differentiation rules. This is 2x plus 1 to the 1/2, okay? And then I've got a function raised to the 1/2 power. So f prime of x would be, okay, my inside function, I have to use chain rule here. Inside function is 2x plus 1, call that u. Outside, u to the 1/2. So the derivative is 1/2 u to the minus 1/2. So f prime of u, okay, that is that. And then the derivative of 2x plus 1 is 2. So du dx is 2. And that is equal to 2 times 1/2 is 1. So, and u to the minus 1/2 is 1 over the square root of u. And u was equal to 2x plus 1. And we got the same thing. Okay. But pay attention. When I say use only the definition, I mean to compute the limit, this limit or that limit. Okay, how am I doing on time? Okay, not too badly. Let's do one off of the September 25th homework. Yeah, the September 25th homework. Now we've learned all the differentiation rules and we are using them. So let's see, let me pick out one here. How about number 15? And this is the September 25th homework. So this was after the first exam. Okay, so I've got f of theta is equal to the secant of 2 theta over 1 plus the tangent of 2 theta. Okay, and this is, now we're using the differentiation rules or the differentiation laws, or sometimes I call it techniques of differentiation. Okay, so, well, this is a quotient of 2 functions. So that means quotient rule. And that says I want the derivative of the numerator multiplied by the denominator. Not enough room. Let me just put it on the next line. Don't really like breaking up lines. Okay, so the derivative of the numerator multiplied by the denominator minus the numerator times the derivative of the denominator over the denominator squared. That's just the quotient rule. Okay. Well, I need the derivative of the secant of 2 theta. And that's actually going to require the chain rule. So I'm going to leave space there. The inside function is 2 theta, u equal to 2 theta. Outside is secant of u. So du dx, d theta, du to theta here is 2. And the derivative of the secant of u with respect to u is secant of u tangent of u. And likewise, okay, so this is secant of 2 theta times tangent of 2 theta, all multiplied by 2. And likewise, I need the derivative of, well, 1 plus the tangent of 2 theta, which is 0 plus the derivative of the tangent of 2 theta. And doing chain rule on the tangent 2 theta instead of secant 2 theta is what works the same way. It'd be secant squared of 2 theta times 2, okay? Because the derivative of tangent x is secant squared x. Okay, so all this is equal to 2 times the secant of 2 theta, tangent of 2 theta, times 1 plus the tangent of 2 theta, minus the secant of 2 theta, times the derivative of 1 plus the tangent of 2 theta, and that's 2 times the secant squared of 2 theta, all over 1 plus the tangent of 2 theta, all squared. Okay, and okay, did not ask you to simplify. You're not going to try to use this to find a critical number or something like that. Leave it like that. You don't need to simplify further. I guess what could you do? You could factor out a secant in the top, secant 2 theta, and I don't see much else that you could do. So I doubt it simplifies much at all. Okay. Any questions so far? Are y'all still there?
Yes, ma'am.
Okay, thank you. Okay. Okay, so how about a problem from the October 2nd homework? Let's see. October 2nd homework, that was the higher order derivatives, implicit differentiation, velocity type problems. Yeah, a silver dollar dropped off a building and that kind of thing, and a projectile shot up from the surface of the earth. Finding some tangent lines and a related rates problems. Oh, let's do related rates. How about number 12? This is a related rates problem. Okay. So it says rain is falling into a cylindrical barrel. At the rate of 20 cubic centimeters per minute. If the radius of the base is 18 centimeters, well, that's not much that's a really small barrel. That's what it says, though. Okay. Is 18 centimeters. How fast is the water rising? Okay. So I'll draw a picture. You got this barrel here. It's a tiny barrel. Okay. I think of barrels as being big. 18 centimeters. It's more like a vase. But okay. So rain is falling, and so the barrel's kind of filling up, and the level of the water in the barrel is increasing as time goes. Okay, so the height of the water is changing in the barrel. And what's the basic rule here? Well, what's the volume of a barrel? It's a cylinder, so its volume is pi r squared h of radius r and height h. Okay. But our volume is changing. Okay, what's changing? So the volume is changing. So V is V of T, the volume of the water, not the volume of the barrel. Volume of the water is changing with time, and so is the height of the water. So H is a function of time, okay? Now the radius does not change. That's fixed. It's 18 centimeters. R equal to 18 centimeters. That's constant, okay? Okay, so in our problem, we have V is pi times 18 squared times H. And that means that dV dt, the rate of change of the volume, well, pi times 18 squared, that's just a constant. But then it's dH dt. So, okay, here are related rates right there. Okay, dB dt is a rate, dH dt is a rate. They are related by this equation. And let's see, we were given dV dt. Okay, That's how fast the volume is changing. It's 20. Okay. So dVdt is 20. And that means that 20 over pi times 18 squared is dH dt. And that's the answer. The water is rising. At the rate of 20 over pi times 18 squared centimeters per minute. Yes. Okay. So that's the solution. Any questions? Okay, after that was October 2nd, and then you had your second exam. Let's see, how about October 16th homework? Okay, by then we were into finding critical numbers and absolute minima and maxima for functions on a closed interval, continuous functions on a closed interval. We talked about the intermediate value theorem, the extreme value theorem, and the mean value theorem. And also we had the beginnings of curve sketching. So increasing, decreasing, local minima, local maxima, concavity, all that stuff. Okay, so how about I do one of those absolute maximum and minimum problems. Oops, what time is it? Okay, I got time for one more. Okay, and let's see. Well, we're going to be wrapping things up on Monday, but I'll try to finish doing one problem off of each homework. Oh, let's see here. A lot of you didn't, when I gave one of a problem like this on the exam 3, I guess it would have been. A lot of you did not recognize it. So let's see. 2C. I just pick one at random. I'm going to use the extreme value theorem here. And that says that if f is continuous on AB, so f is continuous on a closed interval. This is not true. This theorem is not true if you don't have if the function being continuous and the domain being a closed interval. Okay. Then f has an absolute max and an absolute min. On that closed interval, you're guaranteed it. You're using it, but not directly. The fact that the extreme value theorem holds is why you can always do this. Okay, f of x is x over x squared plus 1. And the interval was 0 to 2. Okay, so this function is continuous over the interval from 0 to 2. Note that the domain of f actually is all the real numbers. because x squared plus 1 cannot be smaller than 1. Okay, so it's definitely continuous on the closed interval from 0 to 2. Okay, so how do you find these? Well, we need to evaluate f at the endpoints. I'm going to make a list. And the endpoints are 0 and 2. And we also need any critical numbers in the interior. So that means taking the derivative. Okay, so 1 times x squared plus 1 minus x times 2x over x squared plus 1 squared. That was quotient rule. Okay, just checking my arithmetic there. Okay, so we get x squared plus 1 minus 2x squared and that's minus x squared plus 1 over x squared plus 1 squared. Okay, so critical numbers, we want to set that equal to 0. Here, you don't get any critical numbers from f prime not existing. This f prime always exists because, again, the denominator is always positive. That would say...
Wouldn't that be equal to 1 over x squared plus 1? Or, I mean, negative 1 over x squared plus 1?
Negative 1.
The
Okay.
derivative.
Okay. Okay. Well, let's. All right. So the derivative. Okay. So let's go through that again. The derivative of the. Okay. Do you agree that this is a...
Yes, ma'am. But what meant is on the last part we have, it looks like, at least to me, that the numerator is roughly equal to or could be removed from the denominator.
Removed? Okay. Okay, Mr. Levy, let's see. We're probably getting our wires crossed. Do you agree that that's the derivative and that's equal to that first?
Yes, ma'am.
And that's equal to that.
Mm-hmm. Yes, ma'am. But kind of what I mean is like the top one would be equal to negative 1 times so x squared minus, oh wait. Oh.
Yeah, you're right. You're right. You're right. Okay, this all boils down to, let's see. You're right. All right. The only way this can be equal to 0, can we write that? That equal to 0 is that the numerator is 0, right? Because the denominator is never 0. In fact, the only way a fraction can be equal to 0 is for the numerator to be 0 and the denominator not to be 0. Okay, well, the denominator is never 0. So this implies, I think this is what you're getting at. This means I need to solve that. And, okay, that says that x is plus or minus 1. Well, minus 1 is not in my interval. So it doesn't count, okay? But the plus 1 definitely is. So plus 1 goes in my list up here. And then all you have to do is evaluate your function. Okay, so f of 0 is 0. f of 1 is 1 over 2. And f of 2 is 2 over 5. Okay, so I have 3 numbers. My absolute maximum is the biggest one, and my absolute minimum is the smallest one. What's the biggest number in this list?
It would be 1, 1/2.
Yes. 1/2 is the absolute max.
And 0 would be absolute min.
That's right. 0 is the absolute min.
I
Okay.
don't think people missed what it was. I think people missed like the fraction. It's hard to tell which fraction's bigger than which one.
Okay. Well, okay, but all right. If you don't know, okay, is 1/2 less than 2/5? Well, that would say that 5 is less than 4. That's not true. So it must be the case that 2/5 is less than 1/2. That's not too hard to tell. I agree. Sometimes when you have 3 plus the square root of 7, and then you have the tangent of 14, it's like, which number is bigger? There you pull out a calculator, or you think about it somehow, you figure it out. Okay. When I gave this on an exam, an absolute minimum and maximum problem, you all, a lot of you treated it like a curve sketching problem. For an absolute max and min, you don't have to go through all that. Okay. Now, it definitely has to be this situation, continuous function on a closed interval. But all you got to do is check your endpoints, check any critical points, make a list, put them back in your function. The biggest number is the max and the smallest number is the min. And I am definitely out of time. So happy Thanksgiving, everybody. Enjoy yourselves and stay safe. Yeah, this COVID thing's really awful. And they think, well, that Thanksgiving is going to lead to a whole lot more cases of COVID. And that's kind of sad. So you'll be sick just in time for Christmas. But class is over. Okay. Class is over.
Thanksgiving.
You too. Homework due this weekend.
Hey.
Bye-bye.